Hey, happy Monday to all you children. How's it going? We're going to keep going with notes. Very exciting. So let's go. All right. So we're talking about heat and basically thermal transfer, the last video that you watched. And so today we're going to talk about ways you can generate heat. So there are three ways. The first one is friction, which I'm sure you've heard of before. You can see my picture up here in the corner. And you know, if you rub your hands together, they start to feel warm, and then you can kind of warm yourself up. So you might see people do this when it's really cold outside to warm their body up. The second type is burning. So as you can see, this really cool GIF of fire, obviously. And then the last way is incandescent light bulbs. Goodness gracious, must be a Monday. Can't talk already. All right, the next, sorry, I'm just moving my head all around the screen. The next word we're going to discuss is temperature. And temperature is just the measurement of the average kinetic energy. We'll talk more about that later. It'll make more sense. Okay, here's a big one. Put my head right in the middle for you. All right, thermal conductivity. Basically, it's the ability for material to transfer heat. So the particles are bumping into each other. We talked about the particles and where they were when we were discussing matter. Oh my goodness, I'm not thinking of words today. So I said that a lot of times that it will refer back to the way that matter is set up. So good conductors are usually the same as density. So solids are pretty good because you have to think, remember, we have our solids and they're like next to each other and they're not moving very much. And then we have our liquids who are a little bit more spread apart. And so it's harder for heat to transfer that way because they are spread apart, right? And then the same goes for gas. Gas is all over the place. So it's really hard for those particles to run into one another and basically transfer heat. So that's why I kept reminding you and kept making you play Mrs. Winkler Says, except with solids, liquids, and gases. Okay? Good conductors, we usually think of a metal. We discussed this in the last unit as well. That's why we use pans, or our pans are all metal, is because they conduct heat so well. You don't want to put something in the oven that's going to take forever to heat up. You're never going to eat your lasagna for dinner. So that's why we have to make sure that they're metal so we can eat dinner at a reasonable hour. Otherwise, we'd have to start dinner super early. It would be crazy. All right, next we're going to talk about insulators, thermal insulators. These are things that do not conduct heat well. So these are things you don't want to make your lasagna with, okay? Basically, we use these to protect ourselves from the heat. So you might see these things used when we're talking about oven mitts or things like that, because when I take my metal pan out of the oven, all full of deliciousness and hot gooey cheese and all that, clearly I must be hungry. I don't know what's happening. But you want to use something that's not metal, because if I were to put my hand in a metal glove and then stick it in the oven, ouch, I'm going to burn myself. So instead, I'm going to use a mitten or something like that made of rubber, wood, wool, fabric, or plastic even. There's different like silicones and things like that. All right. Ooh, look how perfect my head fit right there. What are the chances? So we'll get more into sound waves later on, but just for a general definition, sound waves are rarefactions and compressions traveling through a substance. So sound waves, just like the thermal conductors, sound waves have to move through things. And so you actually can't hear if there's no particles there. So it has to move through a solid, a liquid, or a gas. So just like we talked about, when it's solid, sound actually moves really well through solid because those particles are really close together. So it's easy for them to bump into each other. It's a little bit harder through liquid and really hard through gas, which is kind of weird to think about because that's how we talk. We talk into the gas, our oxygen, our air, everything that it's made out of. So, yep, it's got to move through something you can't hear in a vacuum, which we'll get to. Not a vacuum like you need to vacuum your carpet, a different kind of vacuum. Maybe. Okay. So we just talked about that. Sound waves travel really well through solids because they're bumping right into each other. Liquids, they do okay. They still can move. And gases, not as well. And like I wrote this on Canvas, but if I am ever going too fast and you need me to slow down, basically just pause the video. And so if you need to go back to finish writing all this in your notebook, I won't be offended, mostly because I won't know. But I also wouldn't be offended if I did know. All right. To go along with sound, we also talk about pitch. And all pitches is how high or low a sound is. You might have heard this before, maybe in music class. Got my Central Star students may have heard this before. So the frequency of a sound increases when the pitch goes higher. So basically, and we'll look at the waves and things like when we get into the chapter of sound. And here are some facts about light and sound. Sound actually travels at 767 miles per hour. Whew! That is fast. That's why when I say something, you can hear it right away, essentially. Light travels even faster, 186,000 miles per second. That's bananas fast. So basically, light travels a lot quicker than sound does. So that's why you always see the lightning before you hear the thunder. Well, fun fact for you on this Monday. Morning or afternoon, I don't know when you're watching the video. Next, we're going to talk about light. So light is made up of electric and magnetic energy. Oop. Okay, light travels in a straight line only. So it only goes straight. And again, we'll get more into it when we are reading about it. I'll give you some more examples. But it can refract and bend. So that's a big part of what we're talking about. So as you can see on your screen right here, we have a pencil. And we know that this pencil is not broken, but in our heads, it looks broken, right? So it looks like it ends right here and starts again right there. And that property is just called refraction. So basically, it's the light bending it. So it's making it look like the pencil is broken, but the property is just refraction. It's going to be on your test. Make sure to remember refraction. Boop. There's my head. Okay, next we're going to talk about, and I think these should be reviewed for you. I'm pretty sure you guys have gone through this before, but just in case, we're going to go over it again. So we're going to talk about 3 different, oh no, now you saw it ahead of time. Sorry. Okay, so we're going to talk about 3 different ways that light can go through things. So the first one is translucent. So basically the light comes through, but it's blurry. You can't quite see. A lot of people will use these there's like glass blocks that people will put in their shower or maybe your shower door. You can still see kind of like the outline of things, but you can't see through it. It's like a frosted kind of look. So translucent is the one where basically it blurs everything, but you can still see light. So when you think of translucent, you can think of bathroom door, or sometimes people do it in the front of their house too. They're looking for some more privacy. Opaque is no light passes through it. It's just like a board. It's like a piece of cardboard, a piece of wood, the table, the wall. So the way I think of it, and this is really cheesy, but whatever works, right? So I think, oh no, opaque. You can't see through it. Oh no, you can't. No light. I don't know why that is what sticks in my brain every time I say opaque, but if it helps you, you can think to yourself, oh no, opaque, and then it works. So, like I said, really cheesy, but these are the things that are going to stick in your brain until you're like 40. It's going to be lovely. Okay, the next one is transparent. So those are your windows and the things you can see through. My blue light glasses here. Anything that you are able to look right through, and most of the light comes through and you can see pretty clearly. Now, the reason I have this family right here is because I have another trick and to teach you how to remember transparent. So we remember, oh no, opaque. And then we can also remember transparent, because I always think of the phrase, parents can see right through you. You're like, what? So, when you're, maybe don't tell your parents the truth sometimes, and maybe you snuck an extra piece of Halloween candy, but they always find out, they somehow always know. And so that's why I think of transparent. Your parents can see right through you. They knew you ate that Milky Way bar. You probably have some chocolate on your mouth, and the candy wrapper is still in your hand. They figure it out. They're very smart. Parents, I tell you. Whew, what would we do without them? So, parents can see right through you. Transparent. We can see right through those windows or your glasses or other objects. Okay, the next one is basically it's the acronym for the rainbow, because we need to know the different colors on the spectrum. So you can remember it, Roy G. Biv. Sounds like a really nice guy. Just kidding, it's not a guy. It's just all the first letters of all the colors in the rainbow. So if you can remember Roy G. Biv, you can remember red, orange, yellow, green, blue, indigo, and violet, which are all the colors. And we'll talk more about colors and prisms a little later on. But Roy G. Biv, don't forget it. All right, frequency is just the vibrations per second. Is that my last one? Oh, goodness. Let me double check. What do you know it is? All right, ladies and gentlemen, I'm sorry. I thought I had one more on there, but apparently I do not. So with that, I will let you go. You have a fantastic rest of your Monday, and email me if you have any problems. Sound good? All right. See you later. Bye, guys.